Hello students, welcome to my channel Edu Scription. We are in the fourth lecture series of engineering thermodynamics, moving to the third chapter, work and heat transfer. This is lecture 1. Okay, if you have missed my previous 3 classes, there is an I button above that one. You can click and go for the previous 2 classes regarding temperature and the basis of the thermodynamics. So not wasting much more time, let's start work and heat transfer. In a closed system and its surrounding can interact in the two ways. The first one is the work transfer and second one is the heat transfer. So now we'll move for the work transfer. Generally we know work means W is work into force into displacement. Okay, so work is done by a force when it makes the body to move from one place to another. So in thermodynamics, the work transfer can be considered as a positive when the work is done by the system and negative when work is done on the system by the surrounding. Just see the figure, just you have to remember because you have to do the problems on this basis on work done. So if this is the system, if work done by the system occurs, okay, when work done by the system, it always take as a positive. If it is work done on the system, work done in the system, so it will be taken as a negative. You have to go through the words. If it is written work done in the system is 30, means that W is given as a minus 30 kilojoule. So this thing you have to remember for the sign convention. It's a very important one, sign convention. When work is done by the system, it is positive. When work is done on the system, it is negative. Generally, when there is an expansion in the work, it is positive work. When there is an compression, there is a negative work. Okay, so now we will move for the PDV work or displacement work in a closed system. Means we are going to find out the formulae for the work done. Okay, so what exactly there is this? Look, this is a cylinder and this is a piston. Okay, this is the piston is at this point first and the piston area is A. Okay, so let P1, V1, T1 are the properties of a system of gas in the cylinder at initial state. Let in initial state there is a pressure, volume or temperature of gas is there. When then the piston is moving from this place to this place having length dl. So obviously the property will change to P2, V2, T2. So to the displacement, the amount of work occurs will be how much? Now del W, work done is equal to, we know that force into displacement. So force into displacement is how much? dl. Okay, now come to the figure. When there will be F force by the piston, so there will be a molecular force, molecular pressure which will try to resist this one. So this P force will be equal to this F force. Okay, so what is the value of P? So F force will be the pressure of the molecule into the total cross-sectional area of this piston is how much? A. So it is P into A. So in place of F I am writing P into A dl. Okay, now just look this A dl. A dl is the area of the piston into change in length. So it consists of total volume covered by the piston. Okay, so in place of ADL I can write dV. So dV is equal to ADL. It is otherwise called as a infinite displacement volume. Okay, so from this we can conclude that the work done formula is PDV. Work done formula is PDV. Now what we will do, we will find out the work done formula for each processes. Okay, so the first one, so work done for various processes in quasi-static process. Generally the problems we are going to do regarding the quasi-static process means this would be the reversible process. Okay, so first one is the isothermal process. So we know that in isothermal process where the change in temperature remain constant. So isothermal is the temperature constant process is the isothermal. If you will see the PV diagram, this is the pressure, this is the volume. Okay, so we know that it's a quasi-static process, reversible process, so the points will remain same. So P1 V1 is equal to P2 is equal to C is equal to, I can write, suppose if this is P1 V1 and this is P2 V2 and this is a one point is PV, so both will be remain constant. So here P C, so P will be how much? C by V. Okay, So work done formula 1 to 2 integration P dV. We know that in PV is equal to C. So in place of P I can write integration C by dV. So PV integration V by D. So work done is equal to how much? Now PV ln V2 by V1. Okay. So this is the work done formula P1 V1 ln V2 by V1 or P1 V1 ln P1 by P2. Okay, if you will same P1 V1 because both will be same, so simply P2 V2 ln V2 by V1 is equal to P2 V2 ln P1 by P2. We know that PV is equal to MRT, so I can write P1 V1 place MRT MRT1 ln TV2 by V1 or MRT1 ln P1 by P2. Okay. So now we will move for the isobaric process. So the isobaric process means it's a constant volume. Sorry, it's a constant pressure processes. Constant pressure process is isobaric process. Okay, so if this is the diagram, look, this is a constant, so this is constant, so P1 is equal to P2. So work done formula will be simply P dV P V2 minus V1 or MR T2 minus T1. Simply P into, because P is constant, so P into V2 minus V1. So this is isobaric process. Now we'll move for the isochoric process. Isochoric process means the volume remain constant. Volume remain constant process is known as a isochoric process. If you will see the PV diagram, this is PV. So this will be the straight line because volume remain constant. So always remember the work done formula for constant volume process or isochoric process is always 0 because P dV, this term will be 0. So this will be 0. Okay. So now we'll move for the adiabatic process. We know that in adiabatic process no heat transfer takes place in an adiabatic process. So if we'll see, I have taken an PV diagram. This is P1, this is P2. Okay. So generally adiabatic process given an expression of this PV to the power gamma is equal to constant. If this is satisfied, this is known as the adiabatic process. So now we have to find out the formulae for the work done for the adiabatic process. So it will be P1 V1 to the power gamma is equal to P to the power gamma is equal to PV to the power gamma is constant because it is a quasi static process. So P will be your C by V gamma. So if we will evaluate work done integration P dV putting the value of C V gamma, so it will be work done W12 will be P1 V1 minus P2 V2 by gamma minus 1, or it will be P2 V2 minus P1 V1 by 1 minus gamma. Okay. So this is the work done formula for adiabatic process. Okay. Now the last one is the polytropic process. So for a polytropic process, what is a poly? If it satisfies PVN is equal to constant, this process is known as a polytropic process where N and C both are constants. Okay. This process is known as a polytropic process. So what will the work done here? Work done formula will be same P1 V1 minus P2 V2 by N minus 1, or it will be P2 V2 minus P1 V1 by 1 minus N. Okay. So this is all about work transfer. In the next video, we will go for the heat transfer. Thank you.